All right. All right. So this is the man. This is the man,
I
the
don't know about
legend
that.
in his own mind. So let's bring that higher.
Oh,
Yeah, bring it up
slipped
higher
on me.
because yeah, well, you know what to do is put it on the center. Yeah, that's probably better because it'll be your fabric.
All right.
That is perfect. Joseph Schoemaker, thank you for joining in. Now, you need to tell everybody out there who you are, and please include your committee work on the National Electrical Code.
My name is Joe Schoemaker. I'm the manager for field application engineering for the Bussmann division of Eaton. I'm a voting member on code making panel 11 and a alternate member on code making panel 9, which covers 11 covers mostly motors and motor application HVAC, and now panel 9 is covering a lot of medium voltage applications.
Right. So again, so you were down. Were you there for 2 weeks at?
I was only there for one, which was enough because I did not expect it to be a high of 25 degrees in Charleston, South Carolina when I went down there, but that's what we had to live with at the time.
It was a little chilly. So I always associate Bussmann with, obviously, fuses. I mean, everybody knows Bussmann has fuses, and I made this statement earlier. Tell me if I'm right or wrong. In my opinion, the fuse is the fastest acting overcurrent device on the market today.
Yes. So that's where Bussmann has been involved in electrical safety. You know, we started to get, I would say, heavily involved in the mid-90s and worked with the IEEE when they were doing some of the initial stage tests for arc flash to really study that. And, you know, we found what we expected, that current limitation can really help to reduce the amount of incident energy. And where fuses do really well is when you have applications with high fault current.
Yep.
It's really the best way from an overcurrent protective standpoint to help to try to lower that, limit the amount of incident energy.
So in my tutorial, one of my discussion points was around, my tutorial on Tuesday was around the trade-offs of goals and objectives, right? One of the aspects that we talked about was selective coordination. Now, selective coordination, in many cases, especially if I'm applying a circuit breaker, not so much, I'll say that, not so much on a fuse perspective, but on the circuit breaker side of our family, we have increased incident energy because I'm putting intentional delays in my power distribution system, right? Now, we have solutions. We have the arc reduction maintenance switch. We have zone selective interlocking. The value that I see as a design engineer, as a power systems engineer with my background, when I apply fuses at a 2-to-1 ratio, I'm probably buying them because I have high fault currents to begin with. The arcing currents are probably going to be in the current limiting region of that fuse. So when I get my selective coordination by maintaining a 2-to-1 ratio, I have a 20 amp fuse, I go to a 40 amp and above. Say I put a 100 amp fuse, so it's a 100 amp panel board or a 200 amp panel board. I have selective coordination. That 200 amp fuse probably crosses 0.01 seconds around 2,000 amps. So my fault currents are going to be high, probably because that's why I'm doing a fuse. And my arcing currents are going to be in the current limiting region of that fuse.
Yeah.
So I can kill both birds or break 2 windows with 1 stone.
Right. And
with that overcurrent device.
You bring up a great point, because you have to consider, because a lot of times we have selective coordination requirements in the code, not for electrical safety, but for life safety.
Exactly.
Because emergency systems, you want the lights to be on, especially buildings sort of like this one full of people. You want to help to get them safely out of the building in the case of an emergency.
Yep.
So we have requirements in the code for selective coordination that have nothing to do with electrical safety.
Yep.
And that is the nice thing about fuses, is there's no trade-off. The operating principle, simple thermal devices, we don't have adjustable settings and things like that. If you design in that 2-to-1 ratio, you can achieve both electrical safety and life safety with selective coordination with no trade-off.
Absolutely right. And then when you're applying all of your equipment, because so it's the other complication. This is the issue. Applying and creating a power distribution system for reliability, whether it be for selective coordination, for arc flash reduction, you want to limit your equipment damage. You have short circuit current ratings you got to think about. when you're applying an overcurrent device where you're not intentionally moving it around because your fault current is higher, right? You're maintaining the 2-to-1 ratio. You're achieving that selective coordination. You're reducing the incident energy, and you're protecting your equipment with the right short circuit current rating because you're at those high bolted fault current values, which is what we use to evaluate a short circuit current rating on a piece of equipment. You're there, right? Because you've got the current limiting nature. So I can honestly say, and I will be truthful, before we acquired Cooper, we argued and we debated, but now
Just
we have
a little.
it's just a little. But we have now what is very comforting. It's a very good place to be. Is I don't have to care about the solution you put in, right? Because it doesn't hurt any one of our businesses. It brings the right solution to the end user, and you're just keeping everybody happy.
Yeah.
So current limiting, right? So I know current limiting fuse is something you've got going on. Now, the other product that I used to despise and now I love is the cube fuse.
Yep.
I mean, that is a sweet product. And we doing so I know we expanded the solutions there.
Yep.
Did we or did we not?
Yep.
What's going on with the cube fuse?
Yeah. So the cube fuse, for anybody that doesn't know, it's a pretty revolutionary fuse and switch with a compact circuit protector that's a finger-safe device. So It's not like old open-type switches. We made switches that were much smaller and they're finger-safe. So it really boils down to when you look at how do you control electrical safety, and the hierarchy of controls is design out the hazard first.
Oh, yeah.
That's what we're really trying to do with current limitation and finger-safe devices, because you really lessen the chance of something happening when you have all finger-safe. If you drop a tool or something, it's not going to come into contact with energized parts. If your hand's in there, you're not going to come into contact with energized parts. So you really reduce the likelihood of occurrence.
Oh, there's that word, likelihood and severity. So the fuses do a great job at reducing severity, but you can also reduce the likelihood because you're replacing fuses with the dead front on.
Yes, and that's
huge.
Everything that we've developed over the past probably 15 years, we have kind of three basic pillars. We want safety, so things like finger-safe products, current limitation, code compliance, which also facilitates safety, and then space savings, because we all have less real estate to work with, and we're putting more electricity in places where it wasn't before. So those are kind of our three major pillars that we're trying to address with our products.
And to go along with that, we got PPE guy here, right? Because you're in the PPE world, but you're also in another very important function or tool that the electricians out there have for establishing an electrically safe work condition. And what is that?
So that's where we previously stopped at the design and ahead of time. And recently we've gotten into the PPE. And then we looked at how people are working on equipment. And we, like most people in the industry, are encouraging people to establish an electrically safe work condition. So we recently launched our lockout tagout products. And really, we're just have a product, a full line of lockout tagout products now. But we're really getting into helping customers comply with, okay, are they applying everything properly? Are they applying locks? When they're done, are they removing locks? Are they wearing the appropriate PPE? And we're developing products now and tools that we'll be launching soon over the next couple of years to really help people along that path. And again, the idea we want to get people is making it as easy as possible to establish that electrically safe work condition.
Absolutely.
And you need PPE while you're doing it.
Yes.
You need the locks while you're doing it. And so that's where we're going.
Yeah. So now you have the get your water too. So you have a lockout tagout, and here's, like, somebody asked me about personal protective equipment. They were like, "Oh, you guys are into PPE now." I'm like, "Absolutely. You're buying our equipment. You're buying switch gears, switchboards, panel boards. You're buying fuses. You're buying breakers. What better way than to lump some of the things that you probably would have a hard time getting after the fact right into the process?" So now you sit down and say, "Hey, I'm buying a switchboard from Eaton, and I want to expand, or maybe I don't have a lockout tagout program. Maybe it's a brand new facility, and I don't have any of that equipment. Put that right into your main order. That would be sweet. It's the cat's meow."
Yeah, and that's what we still, we still meet with a lot of customers that are on all different parts of their kind of safety journey.
Right.
And we still meet people at the very beginning. We have a lot of tools that can help them out. We can help people doing arc flash studies with our services group. We can help them do training.
Yeah.
And now we can help them actually outfit their people and get the right equipment for their people to make their people safe.
Absolutely. It's all about safety. It's all about keeping people outside of the arc flash zone. And if you're in the arc flash boundary, you bring the severity down.
Yeah, and it's very natural for Eaton because we know as employees of Eaton, we have a very, very safety conscious culture.
Absolutely
and
right.
Everybody should go home at the end of the day the way they started the day. And so we take that culture that we have internally and we want to help other people achieve that same.
Absolutely right. And honestly, being in the booth like this with me is a hazardous location. I'm telling you. Don't you think? Absolutely. I tell you what, there are so many people here and there are so many people in this booth. It is amazing. So what kind of questions are you getting in the booth?
Well, a lot of people, they just want to know what's new. That's why they're here. Most of the people here are very far along in their safety journey. They know quite a bit, and they're always looking for the next thing, the next step. How do I make the system safer? What do you have to offer? Recently, and fuses don't cover every part of protection. So with our safety switch group developing the arc energy reduction switch, where fuses aren't in that range. So they want to know about that stuff. What do you have new? What's interesting?
Oh yeah, that's right. So another big question on everybody's mind is 24067. How am I going to meet that with fuses? Now I know just because, and you know this too, by looking at the size of the fuse, right, and the curve. As you go lower, that curve is moving further to the left on the time current characteristic curve, and your fault currents are higher. So your need for employing an arc reduction technology for, say, a 1200 amp fuse at 480 volts is
probably not
often, if at all, ever, right? Just because of the nature of what is the arcing current in the relationship. And 24067 says it has to clear within 0.07 seconds, right? It's those big, larger fuses. But I always say, you may not employ a product like what's here for the arc reduction maintenance switch on a fusible switch, or this is a circuit breaker switch, but say a fusible disconnect switch. You may not employ that to meet a code requirement, but you may elect to employ it anyway because that arc reduction maintenance switch will help you down further in the system.
Yes.
So whether you have a circuit breaker in a box like what we have here in the booth or a fusible disconnect switch, it's not about the fault current right there at the switch. It's about further down in the system and being able to provide safety for someone working on maybe an industrial control panel.
Right. Or a 200 amp panel board where they don't think there's a hazard, but it's fed by a 4,000 amp switchboard.
Exactly right. So you turn something on and you can provide that arc reduction downstream. So, and we go down further and further in these systems, right? So our ability to provide these types of technologies is just growing even in the fuse industry, especially at Eaton.
And also to help with that compliance, we deal with digital tools. I think you are the one that really developed the digital tool that we have that evaluates whether or not you need that per the code requirement. So you just put in your bolted fault current. We do the calculations per 1584, and then it'll tell you whether the fuse is going to clear that fast enough.
Yes. Excellent. And you know who just walked over? Jay Prigmore. Jay is the chair. He is the chair of the current electrical safety freaking workshop. Yeah. Do you want to come on over? Come on over. Let's do a switch.
All right. We're going to switch it out. Thanks, Tom. I appreciate it.
Thank you. I appreciate it. Jay Prig.